All right, guys, I was going through the quizzes, and most of you have done a fantastic job on them. All of you have done at least some of it really good, so I don't want this to sound like nobody knows what they're doing. But some of you are making number 3 and 4 harder than they actually are. Now, I saw some people come up with some very inventive ways to do them. Not how I would do them, but what they were doing, it worked, and that's kind of cool. I like that. But these two problems are nowhere near as hard as some of you are making them. So let me show you. This is how I would do them. Okay, and then you guys can make some changes to your quizzes if you want. I haven't finalized any of your grades yet. In number 3, certainly the left-hand side is more complex than the right-hand side. So I'm starting on the left-hand side. And this one right here, I would think, let's write everything in terms of sine and cosine. Okay, and so this right here, cosecant, is the reciprocal of the sine. So this would be the same as 1 over sine squared of x. All right, and tangent is sine over cosine, so tangent squared would be sine squared x over cosine squared x minus 1. Now, the reason I went this route is because I know I'm going to get these signs to cancel each other off. Okay, just knowing that I know this is going to put a sign down in the denominator and this is going to put a sign up in the numerator. So this guy goes with that guy. Okay, and so we have 1 over cosine squared of x minus 1. Now, 1 over cosine, okay, that's the reciprocal of cosine, which is secant. So this gives me secant squared of x minus 1. And if you go to your Pythagorean identities, secant squared minus 1 is tangent squared. Okay, so that would be a good one, and more than half of you did it this way. Okay, so it's not like we didn't get anybody to do it that way. More than half of you did, but there were a couple people that did it differently, and it worked, but they're making it more difficult than it need be. Okay, this guy is where I saw some crazy stuff going on with a few people. Okay, and so I'm looking at this guy, and clearly I would say the left-hand side is more complex than the right-hand side. So I think I want to start on the left-hand side. And the first thing that jumps off at me is these two denominators are conjugates of each other. Okay, and so when I multiply conjugates together, I know that I get a difference of squares. So I would find a common denominator here. Okay, so notice over here, I'm going to have to multiply above and below by cosecant minus 1. So here I'm going to have to multiply by cosecant of x minus 1 above and below. Here I would have to multiply above and below by cosecant of x plus 1 above and below. Okay, so right here, I'm going to get cosecant x minus 1 all over. Remember, I'm multiplying above and below, so that would give me cosecant squared of x minus 1. Okay, I'm multiplying two conjugates, so it gives me a difference of squares. Okay, right here, I'm going to get cosecant x plus 1, but notice again, I'm multiplying a pair of conjugates, so it gives me a difference of squares. So I get cosecant squared x minus 1. And notice now that they have the same denominator, I can add them together. Okay, so notice when I add the numerators, the negative 1 and the 1 cancels off. And then cosecant plus cosecant is just 2 cosecant. So that'd be 2 cosecant of x all over cosecant squared minus 1. Well, if you go to your Pythagorean identities, cosecant squared of x minus 1 is cotangent squared of x. Like that. Okay, now I'm looking at this, and I'm looking at that, and notice this guy's a fraction, but that guy's not. So I've got to get this cotangent squared out of the denominator up in the numerator. Okay, well, 1 over cotangent squared, okay, is tangent squared. So this is the same as 2 cosecant of x times tangent squared of x. Okay, once again, I'm looking here, and I'm thinking, okay, why not write things in terms of sine and cosine and see if I can cancel some stuff off and be left with this guy? Okay, so I have 2 times, this would be 1 over sine of x, and this would be sine squared of x over cosine squared of x. And notice I get a sine down here to go away with one of the sines up there. Okay, so let's see. I've got this 2, I've got the sine right there, so I've got cosine squared down below. Okay, so we're in good shape. So in my head, I'm thinking this is like 2 times 1 over cosine squared of x times sine of x. Okay, and 1 over cosine is the reciprocal of cosine, and that's secant. So I get 2 secant squared of x sine of x, and that's exactly what I'm trying to get, okay, right here. Okay, so this one actually is not that tough, and I saw some people doing it different ways, and it worked out, but it took a long time to get there. So just some hints.